Hi everyone. For this question, it said a biased dice is thrown 200 times if the probability of obtaining the digit 1 is 0.35. Find the probability of obtaining the digit 1 on the dice exactly 75 times, B between 65 and 85 times. So from here we have the dice is thrown 200 times. So this is our N. And then probability to get digit 1 is 0.35. So this is binomial distribution. So we denoted X is the number of times where we are obtaining digit 1. So X distributed binomial 200, 0.35. When we observe this distribution, the first condition we notice that N is large, where this N is 200, already more than 50. Then number 2, we can check the mean, where N times P, which is 200 times 0.35, it gives us 70, which is more than 5. And then the third one, we can notice that the probability is in between 0.1 and 0.9. So this distribution fulfill all the criteria to being changed to normal distribution. So it will be more suitable with using normal distribution to approximate this binomial distribution. So to change to normal distribution, we need mean, where it is NP, which is 200 times 0.35, which is 70. Then we need variance, which is NPQ. So NP we get 70, Q we get 0.65, Q is equals to 1 minus P. So 1 minus 0.35 we get 0.65. So here we have 45.5. So X will be more suitable using normal distribution to solve these questions. So with mean 70, variance 45.5. So come to the questions A. We want to find probability exactly 75. So notice here our X is start from binomial distribution, where we use normal distribution to approximate this binomial. So B need to change to normal. Then this status of this question needs to continue using z-score and draw up the normal distribution table finally to get answer. So for binomial, we changing to normal. For this X, we need to do continuity correction, where we need to plus or minus 0.5. If we have exactly 75, so we want to make it continuous, we will plus and minus 0.5. So it will be X in between 74.5 and 75.5. So we make it continuous. Now we reach the status of normal distribution. So from normal distribution, we need to continue change it to standard normal. So to change to standard normal, the value of X need to minus mean over standard deviation. So X will going to change to Z. So when we finding the z-score here, take note we just need 2 decimals. So we rounding up it to 2 decimals, which is 0.67 and 0.82. Then we draw out the normal distribution here, where 0.67 is on the right hand side positive, 0.82 also right hand side positive. So we need this area. So finding out this area is equivalent finding out the probability. To use table, we always remember table only have right tilt table. So we will start from the right tilt table reading 0.67 minus out this right tilt table 0.82. So in table step, we will write reading for 0.67 minus the tail of 0.82. So now we're going to read out from our table 0.67, which is 2514. Meanwhile 0.82, which is 20 0.61. So simplify this to get answer 0.0453. So now we proceed to question B. So for question B, the question is asking the number of time in between. So probability, the number of times of the dice obtaining one in between will be 65 less than X and then less than 85. So in between we don't have equal. So it's just less than. Then we notice that these questions is start from binomial. Then we need to do normal, change to standard, draw out, then only we can find table to get answer. So this is the flow of our method. So to get normal, we do continuity correction. When you have discrete random variable in binomial in between 65 and 85, we change to normal to become continuous. We need the decimal it on this interval. So 65 not include, we can start from 65.5. Then 85 not include means you only can reach 84.5. So in between 65 85, when we change to normal, the boundary will be start from 65.5 until 84.5. So after that, we are going to change to z-score, standard normal, where this x value will go into minus mean over standard deviation. So our z-score only needed for 2 decimal. Then we draw up for this normal distribution where negative will be at left hand side, positive at right hand side. So in between will be this region. To find from the table, we always read the tail part of the distribution. So we have this right tail table and this left tail table also reading as positive value. So to get this region in the middle, we need to take overall of the region where probability total here is 1. We minus off the right tail table, which is right tail of 2.15 minus the right tail of 0.67. So the negative value will read as positive value. So to read this 2.15, it will be 0.0158. Then 0.67, it will be 2514. Simplify this using calculator. So that's all for this. Thank you for watching.